So you should have now a unit circle. You either printed off the one that I had put together or you copied it down from Google Classroom. That's going to be very, very useful for you in this section because now we're talking about plotting angles onto a coordinate plane. Okay, so when we talk about that, we say angle in standard position. So there are a couple of ways or a couple of vocab words that you need to know so that you can understand what we're talking about when it comes to the angle in standard position. So first of all, you have your initial side. Here's your definition. So your initial side is the side of the angle that's on the positive x-axis. Positive x-axis would be this right here that I'm darkening right now. Okay, that would be your positive x-axis. It's the x-axis where the numbers are positive. I'm just going to erase that though, but just so you know what it's talking about. Then you have your terminal side. Here's your definition. So terminal side, think of terminal as it means like an end, okay? So the terminal side is the other side of the angle where the angle quote-unquote ends. So how does this map onto the coordinate plane? Well, thinking about your unit circle, I'm going to go back to it right here. Your unit circle, you have your two axes, okay? Think of this as your, oh God, what just happened? There we go. Think of this as your x-axis, okay? We see that. And then the up and down line is your y-axis. So you're plotting angles onto that coordinate plane. So what that looks like, let's say you have an angle. It always starts here. That would be your initial side. And maybe it opens to like here. And that would be your terminal side. And your angles open like so, and they're usually labeled theta. That's that Greek letter that means an angle. And just as a refresher, you have this on your unit circle. The reason you have your unit circle is it helps you align these angles a little bit easier. But just as a reminder, over here this would be 0 degrees. At the top that would be 90 degrees. To the left you have 180 degrees. And to the bottom you have 270. And all the way around would bring you back to 360. So 0 and 360 are the same thing. If it's negative, you go in the other direction. Here, let me do this in blue. So I would start at 0. Then at the bottom I have negative 90. In the left I have negative 180. Top I have negative 270. And to the right I have negative 360. Okay, so this particular angle that I just drew is positive. You know, because the arrow that's drawn right here is pointing up. So this would be a positive angle that's somewhere between 90 and 180 degrees. So the difference between positive and negative, like I just mentioned, but a more succinct picture. So if you have your coordinate plane here, and you have, I'll draw it in blue, you have your angle that starts here, and then it opens up to here, for example. That would be a positive angle. They might also, don't get tripped up, because sometimes they can open up a lot wider than that. So you might have, for example, something that starts here on your initial side, and maybe it ends all the way around here. Okay, so you have to pay attention to where that angle is pointing. That'll show you if it's positive or negative. So positive angles, a positive angle opens up. Then for your negative angle, I'm going to draw another coordinate plane. Now it's opening down. Your angles always start at the initial side, which is over to the right here. Okay, except for now, instead of opening up, I'm going to open down. So for example, I might have something that looks like this. Okay, that would be a negative angle. You can also have ones that open up really, really wide. Kind of like for positive angles. If I start at my initial side, it might open up all the way to here. And that's still a negative angle, okay, because of the way that the arrow is opening. So negative angle, it opens down. Then you have something called coterminal angles. here's your definition. So coterminal angles are angles that when they're in standard position, they share a terminal side. A really easy way to see this is looking at your unit circle. You can see here, let's look for example at, I'll pick this angle. 45 degrees and negative 315 degrees are in the same position. Okay, they're different amount of degrees, but they end up in the same position. So those would be coterminal. So for example, in your notes then, I'm going to first of all draw a 45 degree angle. Okay, so here's my initial side. It opens up to about here. You can use your unit circle as a reference. That's the whole purpose of it. This is a 45 degree angle. We just saw on the unit circle that negative 315 was the same. So if I start my initial side here and open down instead, but come to that same position, I know that's negative 350 degrees. Again, we just got that from the unit circle. That's why it's there to help you. They're in the same position. They have the same terminal side. However, they're a different amount of degrees. Just as a heads up too, sometimes you can go around the circle more than once, actually. Okay? So for example, you can have degrees that are bigger than 360. So if I go around here once and then open up to where that 45 degree mark was, now I have 360 plus 45, which actually gives me 405 degree. So this would be a 405 degree angle. So sometimes you'll be asked to find something bigger than 360. That's what that means. That's what we're going to do here in the next step. It says, given the initial and terminal sides, find a positive angle measure, a negative angle measure, and an angle measure greater than 360 for each of the figures below. Okay, so in letter A, you have basically a straight line. Easiest thing, go back to your unit circle, and you'll notice if I go straight across from my initial side, that would be over here. Oops. That would be over here at 180 and negative 180 degrees. So, I'm going to say my positive angle, oops, I keep forgetting to switch it back to the pen mode. Here we go. My positive angle would be 180 degrees. My negative angle, again, just look at your unit circle again. You look at your unit circle, it says 180 degrees and negative 180 degrees are the same. So I'm going to say that my negative angle there is negative 180. Then it says find an angle measure that's greater than 360 for it. All you got to do is add 360 to the positive one. So for something greater than 360 degrees, I'm going to shorthand it that way. All I'm going to do is take 180 and add 360. And you can just plug that into your calculator. You should get 540 degrees, which we're not used to seeing degree measurements that big, but that's okay. That just means you went around more than once. So 540 degrees. All right. Letter B, this one's a little bit trickier, okay? You got to think a little bit more on this one. This one, we're looking at highlighted there. But it doesn't tell us what that angle is. It does tell us what this little section here is. It's 25. I know for my unit circle, this is 270 degrees, the arrow pointing down, okay, the y-axis. So the angle I'm looking for is 25 degrees less than that, okay? So all I'm going to do is take 270 minus that 25 degrees that it told me, which gives me 245. So I know this is at a 245 degree angle. So for my positive angle on this one, I can say 245. And then my negative one, you'll notice 245 is not actually on your unit circle, so you can't get this one from your unit circle. So what I'm going to do to get that negative one is just subtract 360 from 245. So if you take 245, subtract 360 to get my negative angle, all you got to do then is type that into your calculator. So 245 minus 360 should give us negative 115 degrees. here's my positive, here's my negative, and then you have one that's greater than 360. So now instead of, for greater than 360, instead of subtracting 360, I'm going to add 360. So I have 245 plus 360. Plug that into my calculator. 245 plus 360. Oops. I typed the wrong thing into mine. You should get 605 degrees. So, again, using the actual vocab words, this means this angle, and this angle all look like this picture. They're all coterminal. They are all the same thing. Go ahead and flip to the next page, and I'll just do one more definition before I wrap up part 1. This definition is a reference angle. So, here's your definition of a reference angle. So a reference angle is the acute angle formed between the terminal side of the angle and the x-axis. So what that means, it looks different in each quadrant. So again, this is quadrant 1, this is quadrant 2, this is quadrant 3, this is quadrant 4, just so you know where we're looking at. So quadrant 1, you might have an angle that looks something like this. It opens like this. That's your theta. Okay, theta meaning the angle measurement. This one, your terminal side and the x-axis is actually just the angle itself. So whatever theta is, that's your reference angle. In quadrant 2 then, I might have an angle that looks something like this. Okay, it opens up into that second quadrant. That would be my theta. Now, if I'm forming an acute angle that's between the terminal side and the x-axis, that is not the angle itself. Here's my terminal side, here is the x-axis, so now I'm actually looking at this angle. Okay, that would be my reference angle. So to find your reference angle when the angle's in the second quadrant, you take 180, because this is 180 degrees, minus theta, and that equals your reference angle. So if theta is 120 degrees, you would take 180 minus 120 degrees gives you 60 degrees. That's your reference angle. Then in quadrant 3, you might have an angle that looks something like this. It opens up down into that third quadrant. And now you're forming the acute angle that's between your terminal side and the x-axis. Again, just going back to that definition. So this angle right here would actually be your reference angle. To find that in the third quadrant, now instead of taking 180 minus your theta, you take theta minus 180. I'm subtracting out that whole top half of that graph essentially, and that gives you your reference angle. Then lastly, in your fourth quadrant, you might have an angle that looks something like this. Opens up all the way down there. Now to find my reference angle, I'm looking at my terminal side compared to my x-axis. So now your reference angle is actually there. So to find your reference angle when the angle's in the fourth quadrant, you take 360, so the whole degree measurement around, minus your theta. And that's going to give you your reference angle. I'm going to practice using these in the next part.